An electrical circuit as shown in the figure, calculate the potential difference across the resistance of 400 ohms, okay, either by applying Kirchhoff law or otherwise, okay. Now let me first rearrange this part. Let this point be equal to A, let this point be equal to B, let this point be equal to C, and let this point be equal to D. Let me rearrange the same sum, in some different shape, okay. So this is over here equal to, so this is the initial wire, this is A, okay, this is B, this is C, and let this point be equal to D, okay. So let this point over here be equal to D. To this we have connected a battery of 10 volt. Between A and B there is a 100 ohm resistor. So I will draw it like this, okay, 100 ohm resistor. Between B and C there is another 100 ohm. Between A and C there is another 100 ohm resistor, okay. So between A and C there is another 100 ohm resistor. Between B and C there is 100 ohm resistor, okay, there is 100 ohm resistor over here. Between B and D there is a 400 ohm resistor, okay, and between C and D there is another 400 ohm resistor, okay. So and the voltmeter is applied across B and D, okay. So the voltage is basically applied across this part, okay. The voltmeter, we have to find out the voltage at this point, okay. Now you can clearly see that we can apply the Wheatstone network, that is 100 and 100, this is 100, okay, not 10. So 100 and 100, where R1 by R2, this is equal to R1 by R2 is equal to R3 by R4, because R3 and R4 are getting cancelled out over here, okay. So basically R1 by R2 is equal to R3 by R4, so the central resistance will be eliminated from this part, okay. So basically there are only 200 and 400 ohm resistor connected in parallel with the 100 and 400 ohm resistor. Equivalent resistance in this case will be equal to 500 ohms, okay. Equivalent resistance in this case is equal to 500 ohms. Both of them are in parallel, so the equivalent resistance in this case, will be equal to 500 and 500 in parallel, it will be equal to 500 by 2, which is equal to 250 ohms. So the equivalent resistance in this case will be equal to 250 ohms. Now the total resistance or the equivalent resistance is equal to 250 ohms. The voltage we have connected is equal to 10 volt. So the current through the wire will be equal to V divided by R, which is equal to 10 divided by 250, which is equal to 1 by 25. This is the total current flowing through the circuit. Now this current will be equally split into two parts. Over here it will be equal to I by 2. Over here it will be equal to I by 2, since the circuit given is symmetric, okay. So we have to find out, so in this 400 ohm resistor there is a current of I by 2 flowing, okay. There is a current of I by 2 flowing through this 400 ohm resistor. We will use the formula V is equal to IR. I by 2 current is flowing, so which is equal to 1 by 25 divided by 2 is equal to 1 by 50 into the resistor is equal to 400 ohms. So basically it will give me the answer as 8 ampere, okay. So the 8 volt, okay. Since we are calculating voltage over here, it will be equal to 8 volt. So the voltage across the 400 ohm resistor will be equal to 8 volt in this given sum.